Okay, so the document here, as I mentioned previously, it is the document. Maybe this is like Microsoft Word document, okay? Or yeah, you have the Hangul file, okay? And yeah, you have a lot of text in your document. And then I want to calculate how many words about theme appears in the document. How many words about quotes appear in the document? How many words about hockey? How many words about baseball? And so on. So in the document one, so we have 4 documents. In the document one, we have 5 words that mention about theme. In the document one, there are 3 words of hockey. So maybe the word is like the hockey team wins, yeah, because we have win here. The hockey team wins from this team, and then the soccer team also win among the other teams. So yeah, maybe that kind of expression are available in that document. So we can have like this number, and this number, and also this number. Okay. And we call it, yeah, factor objects. So this is the factor. So this is the factor of number or array of number. And actually we can use also in the other domain, for example, in the biology, okay, or in the gene feature mapping, or yeah, the other kind of information retrieval. We can also use this kind of similarity. So the cosine measure is a measure to define 2 different objects, okay, or 2 factors. We call it the term frequency factors. And this is the formula. We will do the D1 and D2, and then we want to multiply and divide it by the length. Okay. So the dot means the factor dot product, and the double line, this one, indicate the length of the factor B. So how can we do this one? We can make it as a factor. We have, let's say, we want to find the similarity between documents 1 and 2. I want to see whether the document 1 and document 2, they are similar or not. And the D1 is this one. Okay, 5030. We put it into a factor like this. And D2, yeah, we have this number. Okay, we put also a factor like this. So as the formula mentioned, we have D1 multiplied by D2. So we have, yeah, 5 multiplied by 3, and then 0 multiplied by 0, 3 multiplied by 2, 0 multiplied by 0, 2 multiplied by 1, 0 multiplied by 1, 0 multiplied by 0, and so on until the end. And we get the result 25. What about D with 2 horizontal lines? So we want to measure the length. What is the length? The length is, yeah, we have this value. So we want to measure with its value. So we have 5 square, or 5 multiplied by 5 plus 0 power of 2. Okay, so 3 power of 2. Yeah, so it's the same with this one, 3 multiplied by 2, and 0 multiplied by 0, and so on. And then we will do the power 0.5. You know what is power 0.5? It is the square root. So we want to find the square root of 42. Then the result is, yeah, this number. We will do the same with the D2. Okay. So this 2 line is the same with the Euclidean distance. Okay. So it's the same formula. with the Euclidean distance. And we get the value of 4.12. Then we have the D1 product T2, and we have the length of T1, and we have the length of T2. So we can just fit into the formula, and the result is 0.94. Okay, so what is the formula? We have the T1 dot T2 divided by T1, the length of T1 and length of T2. Then if I can just mention it one more time. So the problem will be 25 divided by 6.481 multiplied by 4.12. Okay. So the result is 0.94. Okay. So yeah, this section is about similarity and dissimilarity. I already explained about the difference between similarity and dissimilarity. You can see again from the first section. And then, yeah, how many are there for the special cases of Minkowski distance? Yeah, until now you learned at least 3. Okay, L1 norm and L2 norm and L max or supremum. Any questions about this section? Question. And yeah, I will move to the second. I will move to the next chapter, which is about data warehouse. So actually, there are still more contents about data preprocessing, and yeah, there are many things that we need to learn, but due to the time limitation, that's all that I can explain until now. And let's move on to the new chapter, which is about data warehouse. In this data warehouse, I will explain about the basic concept of data warehouse and how we can model the data warehouse. So we will learn about the data cube and OLAP and some design and usage and how we can see some implementation. Okay. So I put note here in the data warehouse, we call it, this is online analytical processing or OLAP. If we are dealing with the transactional DB, we call it online transaction processing, OLTP. Okay, so we will take a look. What is data warehouse? It defined in many different ways, but not rigorously. So there is no specific definition, but yeah, we can just say this is a decision support database. So when you want to do like the mining, data mining, or you want to do the data analysis, the company will have a lot of table. The company will have a lot of database. In order to do the data analysis in a good way, you need to have a data warehouse. So the data warehouse will be a collection of all data that will be used for the analysis. So the decision support database is maintained separately from the organizational operational database. So we have two, what we saw before. We have the analytical processing and transaction processing. We need to separate the analytical and transaction. So the transaction will be for operation. So this will be for the operation mostly. But for the OLAP, it is for the analysis. And it supports information processing by providing a solid platform of consolidated and historical data for analysis. Based on one definition, okay, I cannot mention all the definition, but let's say we have, I took it from the book. Okay. So one guy, W.H. Inman, he mentioned that a data warehouse is a subject-oriented, integrated, time-variant, and non-volatile collection of data in support of management decision-making process. So we will learn those subject-oriented, integrated, time-variant, and non-volatile. We call it data warehousing. It is the process of constructing and using data warehouses. First, subject-oriented. Why we can say the data warehouse is subject-oriented? Because it is organized around the major subject. So if your company is a sales company, then you may use the major subjects like customer, product, and sales. But if your product is the university, then it's also different subject. If you are dealing with the sales, so you can see the operational application will be order processing, consumer loans, consumer billing or accounts receivable or claims processing, saving accounts, all those are related with the operation. But when you already have all those data, you need to convert to the data warehouse based on the subjects. What is the subject? The subject is about sales. What is the subject? The subject is about the product. What is the subject? It is about the customer. It's about the account. It's about the claims, and it's about the policy. So the operational and the analysis is different. Focusing on the modeling and analysis of data for decision makers, not on daily operation or transaction processing. Okay, so different between analysis and operation. And we want to provide a simple and concise view around particular subject issues. And we will exclude. Okay, exclude means we will not include the data that are not useful in the decision support process. So if the data is not useful, we will remove. If the data is not useful, we will delete or we will put in another repository. That's the meaning by subject-oriented. What's the meaning by integrated? So when we are dealing with the integrated, it means we need to integrate from multiple or heterogeneous data sources. Maybe in the company, they have the file with Excel, and they also use with MySQL, or they also use with the Google Cloud, or something related with the cloud platform. So in order to make a good data warehouse, you need to combine or you need to integrate all the components. This is the meaning by integrated. Maybe you combine the relational database, flat files, or the online transactional records. So maybe if you are using the Amazon, you use your Amazon Web Service to collect the data, then you will integrate all those into this data warehouse before you do your analysis. Maybe there is a platform called CRM, ERP, or other data sources. So we need to make it into one data warehouse, and we can do reporting. We can do budgeting, or we can do dashboard. In this case, yeah, data cleaning and data integration techniques will be applied. And there are some things that you also need to do, like what we already learned previously. We need to be consistent in the naming conventions. Maybe we need to input the structures. We need to change the attribute measures, and etc. Maybe, for example, the hotel price. So if you have hotel and your hotel is in many countries, if the hotel is in Korea, then you need to use Korean won. If the hotel is in USA, then the hotel price should be in US dollar. If the hotel is in Indonesia, then you need to use Indonesia rupiah, and etc. And the type of tax is different. The type of breakfast is different, and so on. So you need to integrate all those things before you do the analysis. And when the data is moved to the data warehouse, it is converted. So yeah, there will be a kind of conversion between those kind of data. Time horizon. The time horizon or the time variant is also important, because when we have the data warehouse, it is significantly longer than that of the operational system. For the operational database, it is the current value data today or 1 hour before. If we are dealing with the data warehouse, so we provide the information from the historical perspective. Sometimes, people say that for the operational, the time horizon is about 60 until 90 days. So we call this is operational. And you need to update the records. Okay? And then the key structure may or may not contain an element of time. But if you are dealing with the data warehouse, you will have the time span or the time horizon is in between 5 until 10 years. And it has a sophisticated snapshot of data, and the key structure contains an element of time. So you have month, quarter, year. Okay? So it's bigger the time structure rather than the operational. In the operational, maybe hour, minute, second. Okay? So it's about the operational. So the key structure in the database, it contains an element of time explicitly or implicitly. So for example, in the data warehouse data, okay, you will have the attribute time, and the attribute time is the key, and the remaining attributes are the data. Maybe, for example, in the January 2010. So what happened into January 2010? So maybe you will have the sales, and then how many sales that you got in 2010 January, and so on. But the key of operational data may or may not contain time element. So this operational, sometimes they provide the time element, but many times they don't provide the time element. Non-volatile. The meaning by non-volatile is a physically separate store of data, and it is transformed from the operational environment. So we have OLTP. You still remember what is OLTP? It is the online. Yeah, sometimes we call online without dash or online. Yes, it's the same. Online transactional processing. So every operational data will go to the OLTP, and In order to do the analysis, yeah, we need to use a kind of data warehouse. So we need to separate. We need to separate this one. So we'll need to load the OLTP database into the data warehouse database. Why? Because in the OLTP database, you can do read. Okay. You can add, you can change, you can delete. But what about in data warehouse? You can only read because it is for the decision support system. That's why people say that it's better to separate. So it is non-volatile. Operational update of data does not occur in the data warehouse environment. So it does not require transaction processing, recovery, or concurrency control. It requires only two operations in data accessing. So the initial load of data and access of data. The initial load means if your data is very big, you cannot access all the data at once. So you need to have the initial load. Maybe you will load the first 1,000 data. And then, yeah, depends on your role, you can access which data. In these days, there are some architecture to build this data warehouse. And this kind of architecture is the common architecture. So we call it, this is a multi-tier architecture. If you already know, we have this operational database, okay? And maybe there are some other external sources like Excel file, or you have your Hangul file, and etc. And then you can do with ETL. Just to remember what is ETL. Yeah, I think we will learn more later. Okay. It's extract, transform, and load. And after we do the ETL, we will check the data. So some people or some administration officer will monitor the data, and then we'll check what is the metadata repository. So what kind of data that you need to store, what kind of data that you need to save. And we have this data warehouse. Yeah, we will put it into the data marts. So we can separate the data based on the product, sales, customers, and etc. And yeah, we can go to the next step, which is the OLAP server. So we put all of those data into the OLAP server, and finally we will do the analysis. For example, we can do the query, or we can do the report, we can do the analytics, or we can do the data mining. So yeah, at a glance, we can just split between the OLTP and the OLAP. So the OLTP means for the transactional. The OLAP is for the analyticals. The users are different. The OLTP mostly are clerk and IT professional, but the OLAP mostly are knowledge worker. The function is also different. It is for the day-to-day operation. The OLAP is for the decision support. The DB design is also different, because in the OLTP it is application oriented, but the OLAP it is subject oriented. The data itself, it is current, up to date. Detail is also flat, relational, and isolated. But the OLAP is historical data. Sometimes it is summary, and they have multi-dimensional data. It is already integrated. It integrates from all or many sources and consolidated. The usage is repetitive. So maybe after you do something, you can change the data, you can modify the data, or if the data is not necessary, you will delete the data. But the OLAP is ad hoc. Okay? So you have all these things, and then if you want to read it, yeah, you can use it. But if you do not want to read it, then it will just keep in the data warehouse. The access, yeah, we have read, write, and modify, change. But in OLAP, we just do a lot of scanning, scan the data, query the data, and so on. The unit of work is short and simple transaction. So, for example, how many products do you buy today? So you can input and finish. But in the OLAP, it is more complex. So you need to check how many products did the store sales in January 2010, and how many branches that have the similar product with that store. So something like that we can also do with the complex query. For the online transactional, usually we have only a few data, but the OLAP is more, not only million, now it can be billions and so on. The users, because it's transactional, the user should be very small. But if you are dealing with the OLAP, the user will be very huge, because the consumer can access, maybe they can update the number of products that they want to buy. But the OLAP is only for the knowledge worker, only for some people who want to do the decision making. The DB size, actually this one is big enough, but for the OLAP usually is much bigger, because you have a lot of data, maybe from 10 years before, or maybe from 20 years before, and so on. And the metric, we call it the transaction throughput. But in the OLAP, we call it the query throughput or response. Okay. So why we need to separate the data warehouse? So there are some issues. Okay, first is about the high performance. If you put the operational database the same with the analytical database, so the OLTP and OLAP, if we put it in the same part, then it will ruin the system. So because the DBMS, it is tuned for OLTP, like access, indexing, concurrency control, recovery. But for the data warehouse, it requires the query, maybe complex queries, and multi-dimensional view, consolidation. So if you put into the same database, then it will make the performance bad. And different function and different data. If we have missing data, then the decision support requires historical data, which operational DB do not typically maintain. If you have the data consolidation, so the decision support requires consolidation, or maybe you need to aggregate, or maybe you need to make a summary of data from heterogeneous sources. And the data quality. The different sources typically use inconsistent data representation. It might be used different codes, it use different formats that you need to be reconciled. So that's why when you do with the data warehouse, those issues will appear, which is not available in the operational data. And there are more and more systems which perform OLAP analysis directly on the relational database. Okay. So if you want to do with this OLAP, the system will automatically separate, because the time performance will be the issue. So there are three kind of models for the data warehouse. We can have the enterprise warehouse. The enterprise warehouse means this is the whole organization. Let's say you have Samsung. So Samsung is very huge company. So they can put all the data in the enterprise data warehouse. Data mart. So the data mart is a subset of corporate wide data. Maybe you have the headquarters Samsung, but actually they also have a specific or independent data. Maybe you have the Samsung electronic, you have the Samsung electromechanics, maybe you have the Samsung biologics, or you have another kind of Samsung company, maybe Samsung Avalanche, and etc. So they have a specific data, or we call it, this is the data mart. Its scope is confined to specific selected groups. Yeah, maybe sometimes it is related to marketing, or maybe the organization. And it is independent or dependent from the data warehouse. Yeah, it's depending on the need of the company. And now we have the virtual data warehouse, because the virtual is about how we can put all data into the cloud. Yeah. So we can think the virtual warehouse not only the cloud, but if you understand the database, we have view. So view means you can, from the operational database, you can put some views separately, and then you can use this view as the data warehouse. So we call this is the virtual warehouse. So only some of the possible summary views may be materialized. So you can use only the, let's say I have the OLTP, and then I will use view. So view is a separate, we call it, this is the virtual warehouse. And you can use this virtual warehouse for your analysis. So if you understand the database, you can understand this concept. Okay? So the ETL, okay, I think you already know the ETL. Last time we learned a little bit about the ETL, but in this data warehouse, yeah, we will learn more those terminology like data extraction. So the data extraction means we want to get from many sources, from heterogeneous sources, and also from the external sources. After we extract the data, we will do the cleaning. Cleaning, yeah, you know already, if the data contains missing data, or if the data contains errors. So you want to rectify them when possible. Data transformation, yeah, you need to convert the data from the legacy or host format to the warehouse format, because the warehouse format is integrated. Maybe you need to combine the data from Indonesia and Korea and USA and Japan. So it should be in the same warehouse format. Load, it is to sort, summarize, consolidate, compute views, check integrity, build indices, and partitions. So that's why we have the extraction, transform, load. Okay? Because we want to, after we load, then we will get the data that fits for the analysis. And at the end, yeah, we can do like the refresh. It is to updates, propagate the updates from the data sources to the data warehouse. So the data sources, we can say this is the OLTP, okay, OLTP from the transactional processing, and we want to put it the data into the OLAP or the data warehouse. Yep, you already learned about the data warehouse. There are 4 characteristics. What are they? You have subject oriented, and then integrated, and time variant, and non-volatile. Okay. So what is the main difference between OLTP and OLAP? Maybe, yeah, there are so many. Okay. Yeah, this one. Yeah, there are so many differences, but the key difference is the function. It is about the day-to-day operation. The OLAP is about the decision support. There are 3 data warehouse models. Can you mention them? We have the enterprise data warehouse, we have data mart, and we have the virtual warehouse. Explain the main task in ETL. Okay, so you can see from this section. Okay, any questions? No, then I will continue. So we are going to learn some kind of the model about the data warehouse, and yeah, it is necessary when you go to big enterprise. If you go to big company, then you will see this kind of data warehouse. So the data warehouse, as we know, that it is to put the, we need to select some data from the transactional into the data warehouse for the analytical purpose. So the data warehouse is based on the multi-dimensional data model, which views the data in the form of data cube. Okay, so this is the key point, data cube. What is data cube? Data cube, let's say for example, sales. It allows the data to be modeled and viewed in multiple dimensions. In the previous lectures, we learned about drilling. Okay, roll up, roll down, or drill down, drill up. Okay, so they have the key of the aggregation. We can also deal with this one in this data warehouse. So, for example, in the data cube, we have dimension. What is dimension? We have like the item name, brand, type for the item. If you have the item name is pen. Okay, and what is the brand? The brand is Zebra, and the type is multiple pen, ball pen. Okay. What is the time? Okay, the time, it can be depending on the day or week or month or quarter or year. We have fact table. Okay. Fact table, it contains measures. So, for example, how many dollars that you get once you sell, finish your sales. Okay. And the key to each of the related dimension tables. Okay, so there are 2 dimension tables and the fact table. In the data warehouse literatures, we have ND base cube. Okay. We have N means any number or an integer number, and it is a base cuboid. The topmost is 0D cuboid, which is the highest level of summarization. And we call it as the apex cuboid. And we can make what we call as the lattice of cuboids. And the name of the lattice of cuboids, we call it theta cube. What does it mean? Let's see. So we have this data transaction. Okay. So we have the daily transaction. TX means transaction 1. Okay. In this transaction, let's say Hong Gil Dong he, I don't know, he purchased LGTV 45 inches at Yongin Brands in 2020, January 4, and he is paying 500,000 Korean won. Okay, so we call this is the daily transaction. And yeah, the transaction number 2, okay, someone Ilchime, okay, she purchased Samsung refrigerator. The type is 850i at Bundang Brands in 2020 March 7, and he or she is paying 1.25 100,000 won. So if we want to create a data cube, we have the customer table, we have the item table, we have the location table. So the customer table, all the data are related to the customers. So C01, C02, C03. So the customer 1 is Hong Gil Dong. This is the date of birth, and this is the address. For example, Mo Hyun. In the C02, yeah, Il Jime, and this is the date of birth, and he lived in Bundang, Songnam. The customer number 3, yeah, this name, and this is the date of birth, and he lived in Wangsan-ri, Wangsanbo. The item table is the item or the product name. We have item number I01, and then the name is Samsung refrigerator, and this is the price. Oh, maybe this is yeah, this is the original price. Yeah, but when the sales happen, maybe they have discount, or they use the card, or yeah, they have the voucher to reduce the price. Okay, like this one, a LG TV, the original price is 600,000. Okay, and the supplier is Samsung and LG. And the location table, yeah, this is related with the store. The store is in the Yongin branch, and the other store is in the Bundang branch. So when we want to collect all the data about the sales, we integrate them into one table. So we calculate this operational, we calculate this, we can get the customer, item, location, and the date. The transactional date is this one, and the amount is this one. So if we have this one, then we can put into this cube. Let's say this cube, this is the cube. Okay, we call it cube one, just simple representation about the data. So this is about only the location in the particular time and a particular item. Because we have 3 dimensions. This is the time, then this is the location, and then this is the item. So this cube represents the item, what is item, and then where is the location, and then what is the time. Each cells contain the sales amount of a specific item at a specific location during a specific time. Maybe the total sales of LG TV 25-inch at Yongin branch in March 2020. Okay, so it's called as a data cube. And each dimension may have a hierarchy. So we have day, month, quarter, and year. So this is the lattice of cuboids. So if you want to see this all, okay, so this is the 0D, or we call it, this is apex cuboid. And then if we separate into one dimension, so we call it, this is 1D cuboids. If we have 2 items or 2 dimensions, then time and item, time and location, time and supplier, time and location, item and supplier, location and supplier. So we call this is 2D cuboids. If we have 3D cuboids, then it means 3 variables. And at the end, we have 4D, or this is the base cuboids, which have 4 different attributes. Okay, so we call this is lattice to represent whether you want to use 0 or 1D or 2D or 3D or 4D. You can do something like the increment, or you can do something like the decrement. Okay, the schema for the data warehouse, we can have 3 schema according to the dimension and the measures. Okay, so we have the star schema, we have snowflake schema, and the fact constellation. I think because of the time, I will stop here and I will continue on the next session.